Hi everybody. In this video, we are going to explain how to plot a continuous time signal. The signal that we are going to plot is given here. Y is equal e to the power of minus 1.5x times sine 10x, and is going to be plotted along the range of x from 0 up to 5. So I open here a file in MATLAB, and I have to start with clear CLF, and then I will just start writing the program by doing x, the range is equal to 0, and then I should write the time step. I'm going to move, I'm going to do a calculation every how many seconds. I'll choose 0.01, and the final point in x range will be equal 5 as given in the problem, and then semicolon. So that will give me sketch from 0 to 5 with a step 0.01, but maybe you want to change your limit of x in the future. So it's better to make it general. What you will do, you will say you will start from, let's say, a equals 0 and b is equal 5. That's the end point. And the time step, call it, for example, TS time step is equal 0.01. Because you might change it in the future. So now your x will be written in general. Start with point A and time step TS, and the final point is B. It's the same thing, all right? But it's more general. Then you start writing the function y, and it's giving here y is equal to exponential function minus 1.5 times x, and then times sine 10x, so 10 times x, and that's the function. Well, if you do it in this way, it's not going to work. Why? Because x is a vector, and it has size, it has elements like, maybe 10, 15, whatever. So you cannot multiply this 1.5 times x to sine 10x, because this part, minus 1.5 times x, it's a vector. And sine 10 times x is another vector. So the vectors are raw vectors expressed in this way in the raw vectors. Like if you have like 100 elements and 100 elements, it will not be multiplied in the right way. So what you do, you need to multiply element by element. To do that, you come before the asterisk here and you put dot. So when you do that, then it will allow multiplication element by element. So any operation when you are multiplying raw vector by another raw vector, you got to put dot before the operation. If you are multiplying, dot and asterisk. If you are dividing, dot and then the division mark. If you want to add, dot and plus, and so on. Always you put that when you are doing two vectors and the all raw vector. But maybe you ask why you don't do that with minus 0.15 times x, because minus 1.5 is a constant, it's not a vector. You're not multiplying vector by vector, right? But only when you multiply vector by vector. Now, next you are going to plot, you say plot, and then x-axis will be x, y-axis will be y, and you might want to see clear, so you say line width, to make it clear, and then comma, and then choose 2. 2 is good for me. If you want to change the line width, you can go to the MATLAB document and choose the line width that you feel comfortable with. Then you will use grid to make it easy to see the graph, and then I will put the limit of both axes, x-axis and y-axis, and then I will bracket like that because it's a function. Oh, I'm sorry, that it should be axis s, and then. Of course, when you do, you see, let me just do me like that. Any function has this kind of bracket, but the limit will be expressed by a vector of numbers, so you have to make it like that. So you got one inside. That's where you go to put the limit. First limit, it's the x limit. You want to x start from 0 up to 5. You will say 0 space 5. And the y limit, you want to make it from -1 to +1. So -1 to +1, and you are done. So now the first two numbers is for the x limit and the second two numbers for the y limit. Then if you want to just know what's x-axis and y-axis, you can use x label. So you say x label, x, simplicity. And you want to label your y-axis, y label. And you write y, type y, okay. And if you want to do title also to make it clear for you when you review it, say title, the same thing like x and y label. And just I will make it easy, I'll just copy this equation and put it there so I know I'm just sketching this function. And it's done, right? I'm sorry here, this, all right. So it's done here. So I just got to run the program and see if, oh, there is an error here, line 14, string is not terminated properly. This one, y equal, that's not done properly. So let's do it right. Fix any error. All right, it's done. Let's run again. All right, it's done. And maybe we can see the graph. So that's the graph. Let me make sure that I am sharing the graph in the right way. All right, so you can see it. All right, it's there. Yes. Yeah. All right. So I hope that you see it. Well, I hope you enjoyed. And next video, I'm going to show you how can you plot a discrete time signal. Till then, see you then.